Okay, the chapter is inferences from two samples. We already covered the first section, and then this is our second section from this same chapter. In previous section, we used two sample and they were independent sample. And this time, we are using two dependent sample, but that dependency comes from some kind of pair. Okay, so this section presents methods for testing hypothesis and constructing confidence interval. The same thing we did in previous section. We tested hypothesis and then create the confidence interval involving the mean. But in this section we involve the mean of the difference of the values from two populations that are dependent, in the sense that the data consists of matched pair. Okay, so keep in mind, from two different populations, they are dependent population, we find difference between them, and then we use that data as a sample data and we do the hypothesis testing. So when designing an experiment or planning, using the dependent samples are very useful than better than using two independent samples. So first of all, we try to do the hypothesis test here. Use the difference from two dependent samples, matched pair, to test a claim about the mean of the population of all such differences, and then create the confidence interval. How do you do that? So these are the symbols we are going to use. D stands for difference between the two data. Mu D stands for mean of that difference. A mean value of the difference D for the population of all matched pair of data, and that's the mean value for the population. D bar stands for the mean value for the sample, the difference of that, we find the difference between the two samples, and for that data the mean value is D bar. SD stands for standard deviation for the sample data, where the sample data is coming from the difference, and N is the number of pairs of the sample data. So these are the requirements to do the inference about the difference from the matched pair. Sample data should be dependent. Matched pair are a simple random sample. So either the number of pure sample data should be large, which is greater than 30, or the pairs of the value have differences that are from a population having a distribution which is approximately normal. So it should be true. One of them should be true. Okay, so this is the formula for the test statistics. After finding the test statistics, we use p-value or critical value test, and then we conclude our hypothesis. Okay, and this is how we find our confidence interval. This is our margin of error. The same kind of thing we did in previous section, but in previous section we had two samples. Here we also have this two samples, but from those two samples we find the difference between those sample values, paired values, and then we try to find out this type of information for only one sample, like we did in previous chapter. Okay, in previous chapter we talk about one sample test. Okay, so how do you do that? You can follow this step. First of all, you need to verify your sample data consists of dependent sample or matched pair, and verify that requirement, previous requirement, this requirement should be true, and then now find the difference and find the mean of that difference and do the hypothesis testing. So these are the things we do. These are the things we do in this section. So let's look at some problem from this section. Number one, listed in the accompanying table. So this is the table we have given. Are numbers of hospital admission in one region due to traffic accidents on different Fridays, falling on the 6th day of a month and following 13th day of the month. So these are the data. Friday 6th, these are the numbers. Friday 13th, these are the numbers. Assume that we want to use 0.1 significance levels. This is the value of alpha, to test the claim that the data support the claim that fewer hospital admission due to traffic accidents occur on Friday the 6th. So Friday the 6th, fewer hospital traffic accident occurs. That's the claim. Friday the 13th, identify the null hypothesis. Remember, the null hypothesis means the population mean of the difference, it's always equal to 0. Okay, the mean difference is always equal to 0. That is your null hypothesis. So the mean difference should be always 0. And what is the alternative hypothesis? As you can see here, the claim is Friday the 6th should be less than the Friday the 13th. So what is the claim? The claim is the data support the claim that fewer hospital admission. So 6th should be less than 13, and this mu of d represents the difference of the value 6 minus 13. So it's supposed to be less than 0. Okay, if mu of d is less than 0, that means the data on 6th day is less than data on 13th day. Okay, let's go to this problem. Okay, we have given data here. Listed in the accompanying table are heights in inch. So this is the pair of height between mother and daughter in inch. The data pairs are from a journal kept by Francis Galton. Use the listed pair sample data and assume that samples are simple random samples. So the requirement for this test is already satisfied. The difference have a distribution that is approximately normal. Use a 0.05 significance level to test the claim that there is no difference in height between mothers and their first daughter. There is no difference. That's what we want to find out. So in this example, mu of d is the mean value of the difference d for the population of pairs of data where each individual difference d is defined as a daughter side. So you have to subtract mother height from the daughter side. So d stands for this second row minus the first row. So we want to check this null hypothesis, which is the highest difference is 0, no difference. And then our claim is, look at here, there is no difference in the height between mother and first daughter. That's our null hypothesis. So that's the claim. So opposite of this is not equal 0. Okay, so that's alternating. So what is the t-value? How do you find the t-value? Just click here, copy your data in StatCrunch, and first of all, remember we're trying to find the t-value, test statistics for the difference data. So first of all, we need to find the difference between these two values. And remember, the way we are finding the difference is daughter minus mother. So when you go to the data and there is a compute and then click the expression, that will build the difference between these two values. So just click build and select the data for daughter and minus mother. So we would like to calculate daughter data minus mother data, and then just do the OK. And now name that column as a D. D stands for the difference. When we do that, it will create the difference between these two data. Good. Now we would like to find the test statistics for this data. So we go here, stat, t-stats, one sample with data. If you click that, you will be able to see this column D. Just select the D, that's the difference. Now we would like to do this hypothesis test where the mean is 0, and then alternating hypothesis is not equal to 0. And then our significance level, in this case, it's given, where is that? It's supposed to be here, 0.05. Yes, so 0.05, and just hit compute, and it will provide you all the data you are looking for. Like t-stat, it's a 0.728, and this is the t-stat, but you have to round it to the 2 decimal place, so it would be 0.73. 0.73, that's your t-stat. Now what is the p-value? If you go back to that very same table here, the p-value is 0.485. 0.485. And then finally, compare this p-value with the significance level, which is 0.05. As you can see here, this is greater than significance level. So if you go back to your previous chapter, this is the result we have from the previous chapter, which is if p-value is greater than alpha, which is significance level, then fail to reject the null hypothesis. Okay, so this is the conclusion we're going to make. Does the original claim contain the condition or equality? Yes. And then do you reject the null hypothesis? According to this, yes, fail to reject the null hypothesis. So this would be our conclusion. There is sufficient evidence to warrant rejection of the claim. So we go back here. So since the p-value is greater than the significance label, fail to reject, meaning do not reject the null hypothesis. Remember, if p-value is greater, fail to reject. And there is sufficient evidence to warrant rejection of the claim. No, there is not. If you go back to this conclusion, what is that? Here, there is fail to reject. There is not sufficient evidence. So that is what we're going to select. There is not. Check answer. And that's your right answer. Okay. So the only difference between this section and the last section of previous chapter is here you need to create the data first by finding the difference between two data. Okay. So here we have given data between actress and actor ages who won the Academy Awards. So listed in the accompanying table, this table, there are 73 ages of the actresses and actors when they won Academy Awards for their performance. Each pair of ages from the same year. Use the listed pair sample data and assume that samples are simple and random samples, and the difference have a distribution that is approximately normal. These are the requirements to use this test. So now the question is, use a 0.05 significance level to test the claim that Oscar winning actresses tend to be younger than Oscar winning actors. So that's the claim. In this example, mu of d is the mean value of the difference d for the population of all pair of data, where each individual difference d is defined as the actor's age. So in this case, you subtract from actor's age, you subtract the actress's age from the actor age. Okay. So what is the null hypothesis? The mean of the age difference is 0, and then the claim is the actress's age should be less than actor age. So it's supposed to be greater than 0 because this is the difference between actor minus actresses. So if this difference is positive, then that would be our claim. That will tell us, okay, the actor age is greater than the actress's age. Okay, so we did that. So now let's check. What is the t-value? For that, you have to repeat the same thing like we did in previous problem. You have to copy that data in statcrunch, and then first of all, you have to compute the difference between them. So by going data under data, there is a difference expression build actor. First of all, remember it's actor minus actresses. That's how they are defining the difference. Okay, and we would like to name it like a D. That's the difference between them. And now for this data, we would like to find out t statistics with the data. D is our data. We would like to do this hypothesis test. Mu is equal to 0, mu is less than 0. With the significance level, if you check the significance level, it's what is that? It's a 0.05. So 0.05. Yes, that's the significance level. And if you compute, it will give you the t statistics, which is 5.57, 5.57. That is the t statistics. And now for the p-value, there is a p-value as well. As you can see here, p-value is 1. P-value is 1. The meaning is, oh sorry, what did I do wrong here? So the p-value is 1. Did I do something wrong? It's 1. Round to the 3 decimal places as needed. Okay, let me double check it. Oh, look at here. This alternating hypothesis, it should be greater than 0, not less than 0. So let me just fix it. It's supposed to be greater than 0. Look at here. It's supposed to be greater than 0, and I just mistakenly chose less than 0. So for this, the p-value is less than 0.000. If you round it to the 3 decimal places, it would be 0. Now let's check it. Excellent. So as you can see here, the p-value is less than alpha, which means if it's less than alpha, then reject the null hypothesis. Reject the null hypothesis, and this is your conclusion. There is sufficient evidence to warrant the rejection of the claim. So p-value is less than the significance level, reject the null hypothesis, there is sufficient evidence. So that's how we can conclude. For finding the confidence interval, go back to the StatCrunch again, click the option edit, and there is an option for confidence interval. Confidence interval, always to find the confidence interval, you have to find the label as 1 minus 2 times alpha. Look at here, alpha is 0.05, 2 times alpha would be 1 minus 0.1, which gives you 0.9. So if you compute that, it gives you the confidence interval for the lower limit. This is 6.1. For the upper limit, this is 11.2. So 6.1 and 11.2. That should be the range. That should be the confidence range for difference between the average value. Remember, the average value supposed to be 0, but here under the confidence, it's always positive. So that means the rejection of the null hypothesis makes sense. So because the confidence interval includes only positive value, reject the null hypothesis. There is no chance, there is no way from this conclusion we can say, because to fail to reject the null hypothesis only happens if this interval has 0, but that is not the case.